Okay, so in this recording I'm going to be talking about this over here, acceleration of body falling in a vacuum near the Earth's surface with an acceleration g of free fall, and then talking about the equations that we'll use, and then also looking at the effect of air resistance. So with this we're talking about in a vacuum, so basically what we're saying is that we're looking at where there's no air resistance. Now when doing this, we continue to apply our formula that we have. If I just go to our data booklet here, we will use these formula again, our equations of motion, with addition with remember the one V is equal to U plus AT, don't forget that one. Now in each case here, we will use, instead of using A, we will actually change this A into a G. So all of these will be G, where G is given as about 9.81 meters per second. That's meters per second to the negative 2. We will often use G as 10 meters per second to the negative 2. Now basically what this means is that if I drop something from say A and I let it fall under the influence of gravity, that in 1 second, if this initial velocity is 0 meters per second, in 1 second, say it's over there, its velocity would have increased to 10 meters per second to the negative 1, and in another second it would have increased to 20 meters per second. So every second basically the velocity is increasing by 10 meters per second. Obviously therefore the distance that we're traveling is not increasing according to a direct proportion, but it will actually be according to a t squared. Notice this formula over here. If I just look at this formula over here, I've got S is equal to ut plus a half gt squared. So here it's according to the square. So if I double the time, I'm actually going to have 4 times the distance that is actually going to be traveled. So that's important to remember. Now perhaps I can use an applet just to illustrate this a little bit in a little bit more detail. If I can find it here. Where are we now? It's not there, it's not there. That's this one over here. So here I've got something, and I'm actually going to just basically drop this down. So it's got an initial speed of 0. It's actually going to drop just straight down, and if I fire this, as you can see, it's dropping down. Now this distance over here would be in the first second, and this distance over here will be in the second. The velocity here would be about 10 meters per second to negative 1, and the velocity after the second would be 20 meters per second to the negative 1. So when we have a look at this, your initial velocity here, your u in the vertical would have been 0 meters per second to the negative 1. So here we have the thing that you get a uniform increase in velocity. So our acceleration is uniform. It leads to an increase in the velocity or a decrease in the velocity depending on which direction we're going. I'll discuss that in a little bit more detail later on. Okay, so closing that down, going back to these over here. I'm going to do some examples of this, just discussing this over here, this thing about the air friction. Now, when there is air friction, what happens is as the object increases in velocity, the force due to the air actually increases. So you've got an object, say it's falling with a certain velocity downwards. it will have a force down acting on it of mg. So if it's got a mass of m, to have a force. Now as it increases its velocity, the frictional force here will start to increase. It will increase and increase until we get to a situation that the frictional force, sorry, excuse my arrows, when the frictional force, let's call it Ff, when mg equals Ff, the frictional force, then the resultant force, the force resultant, is equal to 0. And at that point, acceleration becomes 0, and we say that the object is falling with what we call a terminal velocity. It's falling with a terminal velocity. And in that case, we will get it often when with skydives and so forth, they will be falling with, say, a terminal velocity of about 200 kilometers per hour. That is when the force of friction equals the force due to gravity acting upon them. Okay, let's try a few examples here, and we can see how they apply. Sorry. Alright, so bringing up my examples. I've actually got 2 examples here. The first one, a person drops a stone down a water well and hears a splash 2 seconds after it leaves his hand. Determine the depth of the well. Alright, so what have we got here? Well, it says drops. What is this word drops meaning? Well, it basically means that your initial velocity is 0 meters per second. You would say throws it down if it had an initial velocity, but the word drops just means it just lets it go. This 2 seconds here is obviously the time, so the time is equal to 2 seconds. And we want to determine the depth, so we're actually looking at to work out what our S is. We obviously know that our G is 10 meters per second to the negative 2. So which formula am I going to use? Well, I've got my U, I've got my T, I've got my G. I'm going to use this formula over here. S is equal to UT plus a half GT squared. And so S, this is equal to 0 because the U is equal to 0. I'm going to get a half times 10 works out to be 5 times 2 squared. That's going to be 2 squared is 4 times by 10 is 40 times by half, 20 meters is the depth of the well. Okay, well that was pretty straightforward. Next one, a little bit more complicated. A girl throws a stone vertically upwards. The stone leaves her hand with a speed of 15 meters per second. Now just looking at this, so we've got the ground there. This is the ground. We get the stone is shot off the ground at 15 meters per second. Now the stone is going to go up and then it is going to fall down. Now it will actually fall down exactly where it's going to go. But at this highest point there, the velocity is actually equals to 0 at a certain point. And it will actually come down with the same velocity. So if this is positive, the final velocity coming down will be minus 15 meters per second. And if there is the time taken to go up, time 1 taken to go up, will actually equal the time taken to come down. So time 1 equals to time 2. The time taken to go up will equal the time going down. So firstly, looking at the maximum height reached. Well, we know at the maximum height reached, the V is equal to 0 meters per second. U is equal to 15 meters per second to negative 1. We know that our acceleration is G. We're going to use 10 meters per second to negative 2. But if I'm saying that my u is positive, then I must say my g is negative because it's in the other direction. Therefore, I can use my formula v is equal to u plus gt. That's equal to 0, so t is equal to, we take the u to the side, it becomes minus 15, and I divide by minus 10, and I get my time is equal to 1.5 seconds. Oh, okay, so that's working. How long does it take to, so I've actually answered the second one. How long does it take to return to the ground? Therefore, it will take 2 times, because this will equal 1.5 seconds. This will equal 1.5 seconds. So the total amount, therefore, time will actually equal 3 seconds to come down. But let me answer 1 now. I don't know why I did 2 first. The maximum height. So here we're going to use, probably we can use this one. V squared is equal to u squared plus 2gs. That's with all the information I've been given. That's 0. This is 15 squared plus 2 times 10 times s. I'll just bring this down a little bit. 15 squared is 225. Now this would be my minus over here. I need to put in, remember I've got minus there. I can maybe put that into brackets there. That becomes minus 225 divided by minus 20 is equal to my s. So that is going to be what? So 225 divided by 20 is, well, you can calculate that for yourself. That will give you your height. Alright, it's that goes into that. Okay, good. So you calculate that. Thank you very much.